All right, so today's lesson is going to be beginning the section on 5.4. This is all about exponential functions. So we're going to have to learn how to find the derivative of an exponential, how to find the inverse, how to find the integration. So in order to be able to do integration and differentiation of exponentials, we have to understand sometimes we might need to solve something, we might need to change its format. And so we're going to review the algebra that you were supposed to learn, I guess, in Math 2 or 3, somewhere along there. And to begin with, as we go through these, what you have to understand, this is all going to be based on E. These exponentials are. They're all base E. So base E is a number, like pi. It goes on forever. It's 2.718 something. So when they say like e to the second power, you don't get a really nice number for it. You get some awful decimals, like you'd get when you work with pi. Okay, we've been working with logarithms, and they are actually called natural logs, such as f of x equals ln of x. And we briefly talked about this one day, but let's get into a little bit more depth with it.
Natural log.
This is called a natural exponential. And the reason it's called a natural exponential is it's based on a number, e. So these two things are inverses of each other. And what that means is that if I wanted to take f of x and switch the x and y in this problem and solve this problem, to get that equation over there, I would put e on each side, because e to the x would stay and ln and e cancel out, making y. If there's anything on that y, it puts e on everything, just like it puts ln on everything, because some of y'all missed that on our last quiz. We had 5y, and you said ln of 5y, and you threw the 5 away. Instead of saying ln of 5, ln of y would cancel out the whatever was on it. So that's how that function comes about when you want to do inverses. If you switch x and y and do both of them to the e power, it makes e and ln drop out. That's one way. The other way I showed you the other day, that y equals ln of x could be written y equals log base e of x. And that when we work questions like this, we usually move the y to the other side, because in these problems, you drop the log and you switch the x and y, so to speak. They switch places. And that's how you can change an ln to an e. Of course, then I'd have to switch the x and y letters, but that's how you do it with that. I like this way better. I think it's easier to understand just taking both to the e power, but that's another way of knowing it. All right, the next thing we have to know how to do is how to change ln to e when it's written in like an expression form, such as ln of 2 is approximately the decimal 0.931. So if I want to know, like, anything with this on base E, okay, then I would take E to both sides, just like I was showing up here. I'll do it in a different color. Make it a power problem. The E and ln would cancel out. And now my E's to a power would be the answer to the question. Although you probably put the 2 on the other end, but that's really just a technicality. Let's look at another one. What if I want to go the other way? What if I want to take something that's already base E change. I'll get out of the way in a second, y'all. I just don't have enough length on this cord. E to ln. E to the 0 equals 1. All right. Change e to ln. What if I have e to the 0 is 1? Is my problem. Well, we know, let me double check, make sure this video is going. Yep. We know that we can put ln on both sides of anything, right? Even if it doesn't have an e in it, you can put ln on both sides.
Would that be log base e to the of 1 equals 0?
Almost. If I put ln on both sides, what happens to e and ln? Isn't that the number that we talked about? Ln of 1 is 0. So it works both ways. If you've got e, you can put ln on both sides. If you've got ln, you can put e on both sides and change it from one format to another.
You're really...
So let's boil this down to an easier rule. Switch two numbers and put the other word. Let me show you that. Well, I need a calculator to make a number because I don't have enough.
It's like old log, right?
It is. It's kind of like old logs. We didn't do as much with E as we did with the LOG, but we did some with it, and unfortunately, we just didn't do the right thing probably with it that we needed to do to make it work. All right. Suppose I have ln of 0.3679 is approximately -1. Let me show you, if you want a quick, easy way to do it, how easy it is. You drop ln and change it to e, and you switch these two. That's all it does. It's that simple. Every time you want to get it, you could just memorize a rule that says drop ln and become e and switch to two things and you'll be done. Isn't that what I did up here? Let's think this through. Didn't ln become e? And didn't I switch these two? Well, let's see. Let me erase everything I got written up here and I'll try it on this one. All right. So ln could become e. I switch these two. Right? Oh, by the way, I'm making an approximate symbol there because that's not exact. That's all you do. All right, let's talk about it if it's already e. Suppose I have, this. Suppose this is my exponential. All right. All you got to do is change it to e at ln and switch these two. How easy is that? So it's just a rule. But if you can't remember the rule, just remember, if you got ln, put e on both sides. If you got e, put ln on both sides, and it'll give you the same answer. It's just this is quicker. All right. Simple enough so far, right? Okay. Now, let's look at some solving questions because obviously this might be important for solving. Because if you've got an ln problem, you might have to change it to e. Or if you've got an e problem, you might have to change it to ln to finish the question. All right. So solving. Suppose I have ln of x equals 2. And I'm trying to figure out what value of x, when you take ln of it, makes 2. Well, I'm pretty sure it's not going to be a whole number. Because 1 comes 0 is the only whole number I can remember off the top of my head. So I could add e to both. Yes, I could do that. We'll do it that way. So if I add e to both, this drops off. And e to the second power is the answer. Or you could just switch it. And the key here is, once I get that, I could leave that exact, or I could give the decimal value for e to the second power. Now, e to the second power means I have to know where the E button on my calculator is, and it's usually on the LN key. For your 84s, it's right above the store, and it's also on the caret key without the caret key. I'd use the one over there on the LN button because it puts the caret key for you. But on your 89, it's also there somewhere where it's easy to find. It's on the, it's with the LN button, but it's on the X key. So it doesn't matter which calculator you use, it's the same concept. I could type E squared by just simply typing the E and putting the 2 for the caret key, because it automatically puts the caret if you use the LN button. And it comes out what? 3, all right, 3, 8. And I think I only rounded this one to 3, so there might be a reason why I did that. I don't know if the directions said that, or if I just knew the answers in the book were all rounded that way. So, but it's okay if you do 3 or 4, because that's the standard. Let's look at another one, because that one's really short. Obviously, they might not all be that short. What if I have an exponential this time? What if I have e to the x plus 1 equals 7? Now, you have to decide sometimes, can I get rid of adding, subtracting, multiplying, dividing? If it's in the exponential, you can't get rid of that adding first. You got to get rid of the exponential first. If this plus 1 was beside it and not up there in the power, I'd get rid of that plus 1 first. Does that make sense?
So you can't just,
I can't subtract 1 from both sides because it's in the power.
why don't you need to?
Well, at some point I do. So how about we do ln first? Because ln will cancel the e out. And then I'd have something I might could do about getting rid of that plus 1, because now he's by himself. Does that make sense? So when I minus 1, I don't minus it from that 7. I minus it from ln of 7. So it's technically, it's this thought. Well, this is the way they probably want it. This might be how you want to type it in your calculator, unless you plan on putting parentheses on both sides of the 7 so the calculator does the math right. Okay. To my personal opinion, ln should be the last thing on a problem, because it's easier to make sure that your number's not inside your ln, especially for the calculators. But this is actually the correct answer. Now, what decimal does that give us? Because sometimes they'll want the decimal.
0.946.
Okay, if I round to 3.946. Okay. And then let's look at one more problem. Okay, so what should I write on the board? Do I need to do that?
No, you can just say x equals 4, because the ln and the e cancel.
Yep. But there's many ways I could do this problem. I could put ln on both sides, but if I do that, then this ln doesn't go away. That would make ln of x equal ln of 4, which is a way of working this question. But if I realize these two cancel, it's a lot shorter, because I already have both of them there. Now, if I don't do that, and I do what you said, and I put ln on both sides, won't that make ln of x? Let me show that, just in case somebody sees one that you can't do the way I just did that one. Oh, wait a minute. Suppose I did what you said. That would make these two cancel, leaving me with ln of x equals ln of 4. How?
Because they're all plus sides.
No.
Well,
Nope. You'd have to bring it over and set it equal to 0 if you do it that way.
wait, couldn't,
Follow me. Subtraction becomes what in division? Now I can put e to both sides. And I have x over 4 equals e to the 0, because these two cancel out. What's e to the 0? 1. Now if I cross multiply, I get 4. I like that one better because he's shorter, but it works that way.
We have to do that entire thing.
No?
I'm just saying, if you put ln on both sides, this is the way it would have to be worked. But if you see these two cancel, see how much shorter it is? Now, this might be the case sometimes that you might have to do something like this.
You have to do it twice like that.
Yes, if there's an E and an LN that didn't cancel something out.
You could just keep working a problem over and over and over again until it cancels.
Mhm.
Pretty much just
Yeah, one piece at a time might cancel out. Usually it'll take 2 rounds if you got both words and you didn't take the fact that they canceled it from the beginning. All right, so that's solving. So sometimes you might have to do LN to both sides. Sometimes you might have to do E to both sides. Sometimes you'll be very fortunate something will cancel out from the get-go.
so you shouldn't end up with more than one LN or more than one E in your finalists.
No, there shouldn't be, not if they're canceling out, no. All right. Although that one, if it hadn't been to the 0 palette, I'd have that E still left. All right, let's look at graphing now. And talk about exponentials in their graphs, and talk about this particular set of questions that I'm talking about right now. I think, if I remember correctly, ask you to illustrate the function and the function's inverse to show the symmetry thing. So it's about graphing f of x, which in this case is equal to e to the x minus 1, and g of x, which is equal to ln of x plus 1. Now, first of all, if you didn't know these two were inverses, is there something you could do to think about it? Well, yeah, one's e, one's ln, right? One's plus, one's minus. That's got a pretty good chance of being inverses of each other because at least they have the opposite things going on. So we know more about ln. Let's start with the ln graph, and then we'll come back and talk about the e graph. We know that that's just shifted 1 to the left. Everybody agree? So there's where my vertical asymptote is. And that usually the very next whole number is on the x-axis, and normally it's on 1, 0. So if the point 1, 0 shifts 1 to the left, it's right here. Everybody agree with that? Have I lost anybody on what our knowledge is about what we've learned so far? Okay. And because this did not reflect, it should look something like that. Would everybody agree with that? Okay. This graph went 1 down. Would everybody agree with that? That's your horizontal asymptote. Because if your vertical asymptote went 1 left, your horizontal asymptote is going to go 1 down. And then your point 0 plugged in here will be 2. E to the 0 is 1. 1 minus 1 is 0. It's still the same point. Did that bother anybody? Okay. Visually, I have trouble sometimes getting my graph going the right way. Okay. E to the x power is a positive problem, meaning it's growth. There are no negatives in that e to the x to make it decay. Do you see that? So there is my inverse function. Now, you could use a lot more points if you would like. You can plot as many points as you need to make you able to graph these. But the basic function is whatever the vertical asymptote is on, the horizontal is going to be on that same number. Okay? And then you plot a bunch of points. And if you do it right, it'll be symmetrical. I just plotted very little, but you could plot a lot more. Now, do you want to see another one? Okay. In our next example, I'll switch it up a little bit. Maybe I'll put some adding and subtracting up here in this power instead of down here beside it so we can see what that does to the graph. Because having adding and subtracting in the 2 different places makes a big difference. Also, Same thing here. This adding or subtracting can be inside, but the adding and subtracting also could be on the outside. So you use as many points off the calculator as you prefer to graph these. You know, if you prefer plotting lots of points, then plot lots of points off your calculator. I don't care. I'm not saying you just have to plot 1 point. I'm just trying to do a rough sketch to give you the important features. So there's a vertical asymptote for LNs and there's a horizontal asymptote for exponentials. Those two have to be right. After that, plot a bunch of points. All right. E to the x plus 3. And g of x is equal to ln of x minus 3. So what did this x plus 3 just do? Left 3. All right.
Is that an exponent?
That's an exponent. All of that's in the exponent. Nope.
No, just the exponent. And the plus, the minus one is there.
Yeah, that's a big difference. I was trying to show you all the two different places. You can have something on the end of a problem, you can have something up in a power. No, this is left, right. The one on the end's up and down.
Just like inside of parentheses and outside.
Like this one. There's nothing in here with this x. This problem does not move right or left, but there's a minus 3 on the end, so that means it goes down 3.
You do.
You might have stretch and compressing sometimes.
But that last one where it was all inside, it was a left or right thing in the G of X.
Yes, it was. That's why I went left 1.
And this one in the G of X.
It's all outside, so it's an up and down thought. All right, so let's do the ln first. ln just went down 3, okay? It didn't go right or left, so that means my vertical asymptote is still in the middle. But my whole entire graph goes down 3. So what goes down 3? Well, go back to the thought that the very point that we know is this one right here. Right? Everybody agree? We know the point 1, 0 is the only whole number that comes out of ln. So if I go down 3 with that, it's now here. Does everybody agree with that? Now I could plot a lot more points, but I'm just trying to give you a rough sketch. So it looks something like that. Now, x plus 3 makes it go left 3, okay? So, in this case, think about plugging in, some values in the question. If I just did e to the 0, that'd be 1, right? Everybody agree?
Which one did you just graph?
I just graphed that one over yonder because I went down 3. All right, so I could go to the calculator and I could get a bunch of points and I could plot them, okay? But what's going to make this power 0? Negative 3. And when I plug in negative 3 and that makes that power 0, e to the 0 is 1. Everybody agree? That's why your problem just went left 3. That's exactly right. Your horizontal asymptote goes across this way because if your vertical is on 0, guess what? Your horizontal is going to be on 0. Now let's talk about this. This point that was at 1, 0 moved down 3. Now it's at 1, negative 3. If you turn that point around, 1, negative 3, don't you get negative 3, 1? So you could just switch the two numbers. If you plot the ln correctly, you could just switch the numbers and plot it. Now you can plot a lot more points if you want to. I don't care how many points you plot, but the main thing to this is to understand, plot the ln first. Because ln has a vertical asymptote at 0, and if it doesn't move right or left, that vertical asymptote stays where it's supposed to be, on 0. Wherever this vertical asymptote is on 0, your horizontal goal is going to be on the same thing. Let's go back and look at the previous example. My vertical was on negative 1, so my horizontal is on negative 1 because it went left 1 on that one over there, right? Everybody agree? This right here said left 1. This said down 1. Well, left 1, down 1. That's where my two lines are. Same thing here. When that didn't have any left or right motion, it kept it at 0. So that meant this one had to be at 0. So you could plot the points off your calculator and put a lot more points on here, probably would be better. Switch the points and replot them. But you need to know where the vertical asymptotes go or and the horizontal asymptotes, because the calculator can't give you that. Where I get my point at is the fact that in this function by itself, ln of x, the only point we know is 1, 0, because when you plug in 1, you get 0. So that's the only point you have to actually know if you don't want to plot points off your calculator. I took that point and I went down 3 and made my new point. Because this is ln of x, so this would have that point, and this says take 3 off, which means go down 3 with that point. 0 minus 3 is negative 3. Or you can just plot a bunch of points off the calculator. But I switched that point to make this one, because then I didn't have to do any calculating up here. But I could have. Well, it makes this 0 is negative 3. That's why I went 3 left. That point was here, and now it's over here. Just like it was here, and now it's here. So you can plot a bunch of points, or you can understand something about transformations to get it. Totally up to you. But you can see they're reciprocals of each other, right? Reflections, symmetry, all that kind of things going on. So the key, they're inverse functions of each other. So the key here is, I don't care how many points you use. If you want to plot a bunch of points off the calculator, go right ahead. If you want to plot a bunch of points off the calculator for this one, go right ahead. But it better look like they're symmetrical. That's what the whole point of this assignment question is. Do they look like they're symmetrical? If they don't look symmetrical, you did something wrong, because it says they are in the directions.
This was in your.
Yeah, it goes in there.
It does?
Yeah, I just throw some cardboard in there once in a while, because it all goes in the same receptacle at home.
Okay, I didn't know.
Yeah. All right, now, let's see. That's derivative work. That's derivative work. That might be all I can go over with this today. So, your assignment for homework on page 344 starts on problem 2 and goes to problem 18, I think. Let me double check. Hold on. Yeah, 18.
Oh, you're done. I just counted. I have 8 more pages, so I have 16.
You finished out your book? All right. You want to grab you another one? You can. Okay.
I have 8 more pages.
All right. So, in our lesson, we have a set of directions that we're going through for the quiz problems. We're going to learn what the directions mean. So, step 1 says use the horizontal line test to determine whether the function is 1-to-1 on the given domain. Therefore, it has an inverse. So, for us to do that, number 1, we have to graph it. That makes sense so far. How are you going to do a horizontal line test if you don't have a graph? Okay. Yep, we got to get the markers to work. All right, so if I plug 0 in, does everybody agree that it's negative 3? Does everybody agree that less than means use negatives? Negative 1 squared is positive 1, minus 3 is negative 2. There we go. It's a parabola, right? No one said this graph had to be perfectly accurate. It just has to be a facsimile, because this is just a rough sketch. Now, in this problem, if this is my domain, what's my range? Negative 3 what?
I can't.
Negative 3 and up, right? I'm just shortening the domain and range thought here. Isn't there going to be y is greater than or equal to negative 3? If I'm using that's just the piece that would go on the end, right? So if that's the case, then because this problem doesn't have both halves of my parabola, will it pass the horizontal line test? Okay. So therefore, the question said, state whether the function is 1-to-1 on the given domain. this function has an inverse, that's an N, because it passes the horizontal line test, which means it's 1-to-1. Y'all can reword that better later when you're making your own. That's probably not the best sentence. All right, any questions about part A? How easy that is. Everybody good? No problems? Everybody feels good about it? Okay, part B. Part B says use the derivative of the function to see if the function is monotonic on a given domain. Therefore, it has an inverse. So here's our algebra, and now we're going to do a calculus. What's the derivative of the original problem? 2x. Now, when you do a derivative, remember a derivative is on the open interval. Whoop, wrong symbol. So I have to take out the equal mark. It can't be equal to 0. It has to be on the open interval. So if I think about values in my chart for x and y that are less than 0, like -1, -2, -3, and so on, what do I know about all the y values in that derivative? They're all going to be negative. All right. So since they are all negative, because my domain is everything below, not including the 0, because if I put in the 0, guess what? They wouldn't all be negative, would they? That's why it's on the open interval. So since they're all decreasing, okay, the function has an inverse because it is decreasing on the entire interval, which means it is monotonic. Did I spell that right? Monotonic? Right?
Yes.
Okay. Okay. Now, the answer to these two questions must be yes for you to move on. If it's no, you stop at the end of part B. But you have to do A and B. Okay? Does everybody understand? If you say no on either of these, it's not going to have an inverse function. Okay? So if you say yes to both, then you do the rest of the steps, which I'm about to show you, because these were both yes. Okay, part C. Part C says find the inverse function. So we're going to take the original function. We're going to put in y. We're going to switch x and y because we're trying to find the inverse function. And to find the inverse function, you have to make the inverse relation, which is why x and y switch. Then you solve it. So I add 3. How do I get rid of a square? Square root. That puts a plus or minus in my formula, but my domain is not for the plus and the minus. So if I restrict my domain, I don't need the plus and the minus. Now, this goes back to what we were just talking about a minute ago. So what is my inverse function's domain and range going to be? Well, the domain of the original problem will become...
So x is greater than or less.
All right, the original domain becomes your range.
X less than or equal to 0.
So we change that to a y. And then what did I say the range was of the original one? So that becomes greater than or equal to Negative 3 for the x. You just switch them. That's why it was important in Part A to get your range in that question. Because then when you get to this question, you can just switch them. All right. Now, why is that important? Because if y has to be less than or equal to 0, is that plus or minus?
Like, no, it's just one.
It's going to be the minus part. Okay. So the key here is, then I don't need the plus part. I need the minus, but I need it over here. So we're going to divide that minus over to here. Because I don't want to leave it on the y. That'd be like saying negative y, right? You can't use the plus and the minus. You can only use one of them. Otherwise, it won't be a function. That's why they restricted the domain. So my inverse function is negative square root of x plus 3. Now, that makes sense if you think about it. Because, first of all, it's square up there, it's square root down here. It's minus up there, it's plus down here. And it's negative because I wanted the part below 0. All right. That's part C. Part D, in the directions, say graph the original problem and the inverse. And I do want that to be accurate, and that will need graph paper. And on your notebook paper where you're showing all your work, you can either say C graph, or you can paste the graph right there, one or the other. Now, I don't need to show y'all how to graph two functions and put a dotted line in it, do I? Y'all good with that? Just, it has to be real accurate, so plots lots of points. All right, so I'm going to move on to E. Part E says, show the composition of F inverse with F inverse F to prove their inverses. This is the algebraic way to prove that you did your math right, getting your inverse function. So we're going to do F inverse of X, and we're going to get an answer. Then we're going to do F inverse of F, which is sometimes why it's better to change it to G, but we're not supposed to be doing that here, but it would be more helpful. So I'm going to put this inverse function, this negative square root, in for the square.
What did you write right there?
F inverse. Yeah, it's a -1. It's a really bad one. All right, I am putting this function inverse in the original problem for x. So our original problem was something squared minus 3, right? And I'm putting this inside of there. Everybody with me? I'm putting the square root problem inside the square problem because the square problem is the original. And the negative square drops off, and the square root drops off and gives me x plus 3. Minus 3 makes x. So we got half a chance that we did the math right on part C. On part over here, we're going to take the negative square root problem with the plus 3, and inside of there, we're going to put the squared problem. Everybody see what I did? I took the inverse function, made a blank inside, and put in the squared problem inside the square root problem. The 3's cancel. The squareds cancel. Okay, I got a problem. Did I mess up something?
The square is greater than negative whenever you square, like with a square root there. Does it get rid of the negative?
No, but I forgot something. Okay, I got it. You just took a square root. What are you supposed to write every time you take a square root? Plus or minus. Okay. Now, let's talk about which half here do we need. All right. What's a negative times a positive? Negative. What's a negative times a negative? So it leaves me, a negative times a plus or minus is still plus or minus, right? Our domain for our function, for our domain for the original function, was all, okay? So that means that I only want the positive part of this one because we're talking about x. Okay, we got to talk about what can x be. We want x to stay positive. So it'll match this one. Now, if we did this right, when you go back up here and do your graph, when you do your graph here, it'll flip over this line. If that was wrong, I'd be using the negative one. If they were both supposed to be negative, I would have flipped it this way. But I'm pretty sure this one flips this way. Okay? So you'll be able to tell which, if you need the positive or the negative, based on your graph you make. Won't flip over positive x. If it don't look like it flipped over positive x, then keep the negative. But then that'd be a problem because they wouldn't match. They got to match because x equals x. And your graph on part D should prove that before you do this math. All right, last step. The last step proves their inverses based on your derivative slopes being reciprocals. Okay? Oh, you need a sentence here. Their inverses because the compositions come out to be the line of symmetry y equals x. They are inverses because the compositions come out to be the line of symmetry y equals x. I don't have that one written on my paper, so I almost forgot to do it. And then last part is F. Prove it. And this right here, when we prove this, we'll prove that plus or minus is right also. All right. What's the derivative of the original problem? That's right, it's 2x. What's the derivative of the inverse problem that we made? Now that's a little harder, right? What do you do with the square root?
Negative 1 over 2 squared x plus 3.
Okay, so we put the half in there. Everybody agrees with that. We put the square root in there of x plus 3. The negative was in front of it, so I got to keep up with that. So I would put that on the top, and the derivative of the inside is 1, so it doesn't affect it.
This is the inverse of what now?
The derivative is inverse. I need a derivative.
Of the inverse.
Yeah, let me put it. I need that notation. What was that notation we had? Was it this? I believe that was that. The inverse derivative.
Yeah, that's how
Okay. So now we're supposed to plug some numbers in here. Now you got to be careful. You will be given a point. And that point that you are given will be for the original problem. So my point that I was given to do this with is -1, -2. So you will plug -1 into the original problem. 2 times -1 comes out -2. What does that tell me about my slope there? It's negative, which means it's decreasing there, right? So I hope this one over here comes out to show something about it. Now, if we put in this problem for the inverse, what number should we be putting in? Why? Because you switch them. This one's point is -2, -1. You have to make the inverse point and plug in the -2, which added to 3 will be 1. The square root of 1 is 1. Times that comes out -1/2, which is also decreasing. But I guess decreasing is important.
From out to that negative 1.
Is it the reciprocal?
Yes.
Yeah. -2, reciprocal, -1/2. They're both decreasing, or they'll both be increasing, but they got to be reciprocals of each other.
So it comes out, if they're both decreasing, one's like 3 and one's like 1/6.
No. And so therefore, since they're reciprocals, we can say they are inverses because the slopes are reciprocals. Where the derivatives have a slope that's reciprocals. And that's how you're going to do each question that you're asked to do.
Question.
Mhm.
Any that stop after A and B?
Yes. There are some that stop after A and B and don't need anything else.
Because I'm gonna be the one that's
Question,
first
can I
that
have
says
all
yes.
of those that end after A and B?
Huh?
May I have all of those that end after A and B?
No.
Let's see, what did you go to?
So what you will have, basically, y'all, is you'll have a linear, a quadratic, a cubic, a fractional, and a trig. And I have given you domains for all of them, and I have given you the original point for all of them. And all you have to do, okay, all you have to do is these steps for each one if it's yes to both. If it's not yes to both A and B, then you stop after B. Okay? Now, any questions about that? So I'm going to post these this afternoon. I am going to post them out in Canvas. Somewhere I have whiteout. I thought. Yay. So for you, Tyler, you're going to be looking in Canvas, but you won't have the directions to look at until you come back to school. So make sure I give you a copy of it.